Okay, again, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you. Right, today we move to third lab, which is regarding the refrigeration system. Okay, during this lab, you should know the knowledge of refrigeration cycling process, and then you should be exposed to the concept of refrigeration system and how to identify the relationship between the refrigeration processes such as compression, condensation, throttling, and evaporation. Okay, in theory, if you see the figure 1 regarding the refrigeration cyclic process, P versus H, pressure versus enthalpy, and then this is the graph of the refrigeration process. Normally, there are 4 processes that available in the refrigeration. Okay, when you look into the process number 1 to 2. Okay, process number 1 to 2. Okay, from 1 to 2 is the compression, which occur at the compressor. Okay, at the compressor. Meaning that, number 1 is the point before compressor. Number 2 is point after compressor. Okay, 1 is before compressor. Number 2 is after compressor. Okay. And then from number 2 to number 3 is the condensation process, which occur at the condenser at constant pressure. Okay, at constant pressure. For example, this one is P2. Okay. Before that is P1. And then the process goes to the throttling process at expansion valve, where the pressure will drop drastically, from 3 to 4, with constant enthalpy. And then the process from 4 to 1, we call it evaporation process, where it occurs at the evaporator at constant pressure. So, and then the process keep repeating from 1, 2, 3, 4, and back to 1. So this is called the refrigeration system process or refrigeration cyclic process. Okay, in the refrigeration, the heat from cold refrigerated space is absorbed by the evaporator or heat exchanger for cooling purpose. Okay, this evaporator is located within the space to be cooled, such as a cool compartment within the refrigerator. Okay, and then the system can be summarized as figure 2 below. Okay, figure 2 below, where the evaporator exists at the cold compartment. Then refrigeration operates with the same principle as in air conditioning system, where it controls the boiling point and condensing the temperature of the refrigerant. Okay, ini you kena take note the medium to transfer heat, okay, is refrigerant. Is refrigerant, not water. Is refrigerant. So the refrigerant will be inside the refrigeration system, and then dia dalam satu sistem lah, inside the system. And then the rating of refrigeration is done by the ratio of cold output to the refrigerated output, and normally we call it as COP. COP, coefficient of performance. Okay, coefficient of performance, COP. Biasanya ada R lah. R is stand for refrigerator. For the next slide, kita ada COP for heat pump. Jadi ada HP. Okay. For the time being, we use COP R. Coefficient of performance R is related to the refrigerator. Okay, tak apa. Okay. This is the refrigeration lab apparatus that exists in your lab. Okay. As you know, we must have 4 main compartment. No, 4 main components. First is, this is because it has compressor. Okay. The second compartment or component is, this one we call it condenser. Condenser. And then third one is throttling valve. Throttling valve. And then the fourth one is evaporator. Okay, and then for refrigerant, okay, for refrigerant, it will exist in the part 9 inside the system. Part 9. Okay, the process start from, okay, before compressor, let's say number 1, after compressor, number 2. Okay, number 1 goes to the inside the compressor, and outside compressor goes to the condenser, and dia pergi atas, dia keluar balik ke sini. And then go to expansion valve or throttling valve. Okay, outside of throttling valve, and go inside the evaporator, and then the outside is here. Outside dia sebelah sini. Okay, sebelah sini. Outside of the evaporator, and then goes back to compressor. As you can see, on top of these 4 components, there are water tank. Water tank here. The function of this water tank is load to the system. Load to the system. Because if you want to, for example, refrigerator, dia ada load kan. So to simulate the same as the refrigeration process, so the load that we're using, the water must have inside this apparatus. Okay, and then you can see here there are several sensors that exist. Okay, there are, number 1 is pressure sensor. Okay. And then we have temperature sensor at certain point. Okay, normally we have a pressure sensor. Saya just tulis P. Before compressor, okay, P, let's say P1. And then after compressor, you also have pressure P2. Okay, and then you also have certain temperature sensors, okay, at certain point before compressor T1, after compressor T2, before goes into condenser T3, okay, then the T4 before throttling valve, T5 and T6 that relate to the water temperature. Okay, and then uh, there are control meter here. Okay, control meter, number one, number two. Okay, that you must read the pressure and T values after certain time. After the process is installed. Okay, to prepare the lab, okay, preparation basically tak perlu, kita siap prepare. Okay, how to do this lab is first you need to switch on the main power switch. Okay, this is the main power switch. The red button, red switch, and then adjust the condenser fan speed to maximum. So this is the condenser punya maximum speed. And then turn on the pump. Also adjust the heater power to maximum. Okay, heater power ni. Heater power ni. Yang tadi ni ialah switch on. Okay, same goes to upper punya figures. Okay, and then let the system run to almost 5 to 10 minutes. And then you record the temperature and pressure reading at the controller. Okay, record the reading and then you need to key in or fulfill the table 1. Okay, table 1. So in the panel there are values of T1, T2, T3, T4, T5 and T6. And also you have P1 and P2. Okay, flow meter, LPM is right here. LPM is right here. Meter TV. And then yang satu ialah compressor power consumption. Value you can see right here. Okay. Oops. Okay, sekarang ni. Okay. Okay, ini yang baru penting ni. Okay, this is the data, raw data from group C. Okay, based on this data, how to transfer this data to the graph. You can refer at the last page. There is a P versus H graph. How to transfer the data to this graph and then determine the enthalpy. enthalpy H1, H2, H3, and H4 to fulfill this table 2 value. Okay, so I go back to the graph. Okay.